All right, so today we're going to be working with trigonometric ratios. We're going to be finding the angles of triangles. So last week we were finding the missing side. So now we're going to use trig to find the missing angles. Okay, so up here to the side, I do have my little calculator ready. But for now, I'm going to go ahead and make this a little bit bigger. Okay, so here we have, it says use a triangle to fill in the blank. Okay, so here we have sine. So sine is our opposite over hypotenuse. Okay, so if we look opposite, we're looking over here. Here is a 4, and this is opposite. So we see, well, what angle is it opposite? Well, it's opposite angle F. So that means that they're talking about the sine of angle F. Okay, not the sine of angle D. Okay, so then here now, next problem, we have cosine of 4 over 5. So 4 is the adjacent and the 5 is the hypotenuse. So how do I know this? This is the cosine is adjacent over hypotenuse. Okay, just in case you forget, let me go ahead and write it down for you guys again. So it's SOHCAHTOA. Okay, so stands for sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, which is where I'm getting this from. So if I look for 4, here is 4. Okay, and my adjacent side, I have two options. Okay, so here's angle D and here's angle E. Both of them touch 4. That's what makes it adjacent. But in this case, E is my right angle, so that's not what I'm talking about. I'm talking about angle D. Okay, so next here we have tangent of 3 over 4. Okay, so tangent is opposite over adjacent. Okay, so this is saying that the 3 is opposite and the 4 is adjacent. So I'm going to go back to my triangle. I'm going to go ahead and erase all these little colors that I have. And we said that the 3 is opposite. So if this is opposite, then directly opposite from 3 is D. So that means here they are talking about D, angle D. Okay, so sine of which angle is equal to 3 over 5? So we need to remember again that sine is opposite over hypotenuse. And in this case, the opposite is 3. So here is 3. So opposite angle 3 is going to be angle D. So here I'm going to put D. All right, cosine of 3 over 5. So cosine is adjacent over hypotenuse. And so here they're telling us that the adjacent side is 3. So I'm going to go over here. Let me go ahead and erase this over here. So the adjacent side is 3. Here's 3. So the adjacent side, you have two options. You have F and you have E. Remember that the right angle does not count. So that means that they're talking about angle F when they say cosine is equal to 3 over 5. Okay. And then last we have tangent is 4 over 3. So tangent, if we remember, is opposite over adjacent. And then our opposite here they're telling us is 4. So I'm going to go ahead and find 4. So here's 4. And opposite angle 4 is going to be angle F. And that's it. Okay. So once we know the sine, cosine, and tangent of Q angles, we can use the inverse trigonometric ratios to find the measure of the angle. So your inverse trigonometric ratios are going to be sine to the power of -1 of x, okay? But we don't say it's sine to the power of -1. We say sine inverse, or we say inverse sine, okay? So inverse cosine is cosine to the power of -1. Inverse tangent is tangent to the power of -1, okay? So here it says, use your calculator to find each angle measured to the nearest degree. Remember to make sure your calculator is set to degree mode. So we are rounding to the nearest degree here. So I am going to, whoops. Take out my calculator. Oh, there we go. And so sine, we're going to use inverse sine. So let me look for my inverse sine. My inverse sine is, oh, we press the second button here. And then I think this A sine. Arc sine, sine to the power of -1. I'm pretty sure it's this one. 1 over, where's the division? Okay, sorry, I'm looking for the division sign, and I do not seem to find it. Let me see. Let me use my keyboard. Okay, so 1 over sine. So 1 over 5, close parentheses, enter. So you can kind of see up here at the top, I don't know if you can see it has sine inverse of 1 over 5. I know it had a sign, which is kind of strange. It threw me off a little bit. But here it goes, 11.5 degrees. So if we're rounding to the nearest degree here, we are going to round to 12 degrees. Okay, and so you do need to make sure that your calculator is set in degree mode. So this little box that I have here, I can see that it has a little circle on degrees. Okay, so then the next one is going to be, 1 second. Okay, so cosine inverse of 6 over 13. So I'm going to press second. I'll see the second button's already pressed. So I knew I had to press a second because of this little -1 that I have here. So second, and then I press a cosine of, let me erase that number, that's not the number I want, 6 over 15. Oh no, 13. We hit enter, and then this one gives me 62.5, so I'll round at 63 degrees. So you can use any calculator. I like using the calculator on my phone because it's very similar to the one that we use in our classroom. But if you do not have it, you can use this Web 2.0 calculator, okay, is what I'm using right now. Okay, so here, I'm gonna go ahead and clear this. We have tangent inverse of 3.4, so I'm gonna press second, and then my tangent, or what it says, a tangent, and then it is of 3.4. So 3.4, and as you can see up here at the top, it does show it to me exactly the way I see it right here. We press enter, and that gives me 73.6, so that would round to 74 degrees. Okay. All right, so here it says find the value of x in each of the triangles. Okay, so just like we kind of started off on the other problems or the previous problems from our last lesson, we first have to figure out which one's O, which one's A, and which one's H. Okay, so this is opposite. Okay, because this is the angle they want us to find, and this one's directly across it. Okay, this is my hypotenuse, and this is my adjacent side. Okay, so we go based off of what they give us. They give us the adjacent is 8, and they give us the hypotenuse is 18. So adjacent and hypotenuse, that is going to be my cosine function of x degrees, we don't know what it is equal to my adjacent, which is 8, over my hypotenuse, which is 18. Okay, now to solve for x, what we're going to have to do is we're going to have to use the inverse cosine. Okay, we have to use the opposite. So we use the inverse cosine to figure out what x is. Okay, so that means that the 8 over the 18, we're going to have to, use inverse cosine of 8 over 18. So that's what I'm going to put here. Let me just delete it. So second, inverse cosine of 8 over 18. Enter. And that gives me 63.6, so that's going to round as 64 degrees. And that's it. Okay, so you use that one to find the missing angle. So here we go, we have another one. So here, this one is opposite, because it's opposite the angle we're looking for. This one's my hypotenuse. That makes this one the adjacent. But really, the adjacent doesn't matter here because they give us the hypotenuse is 9 and the opposite is 6. So that means that we're going to have to use sine. So we do sine of x degrees. We don't know what it is. That's what we're looking for. Equals our opposite, which is 6, over our hypotenuse, which is 9. So to figure out what x is, we're going to go ahead and take the inverse sine to figure out what it is. And then I'm going to have to find the inverse sine of 6 over 9. Okay, and that's what x is going to equal. So I'm going to go ahead and plug that in my calculator. Let me erase it. I'm going to press second, inverse sine of 6 over 9. close parentheses, enter. This gives me 41.8. So that means that that angle x, if we round it, would be 48. Or not 48, 41.8 would round to 42 degrees. All right, the next one. So here is our angle here. Whoops, I pressed the wrong button. And so they give us this side here, which is our opposite. Okay, this side is across the 90-degree angle. That's my hypotenuse. And then the other side that they give us is this side, the 8, which is the adjacent side because it touches the angle. Okay, so this time they give us opposite and adjacent, so that's going to be my tangent function. So tangent of x degrees, we don't know what it is, equals our opposite, which is 11, divided by our adjacent. Okay, so to figure out what x is, we're going to go ahead and have to find the inverse tangent of 11 over 8. Okay, so I'm going to go ahead and plug that in my calculator. So we have second, inverse tangent of 11 over 8. And that gives me 53.9, which rounds to 54 degrees. And that's it. Okay, so let's see the next one. So here they're going to give us some, whoa, I went too far. Okay, number 8. So here's the next one. Here's an angle. So this one is opposite the angle. And this one is my hypotenuse. So then opposite and hypotenuse is going to be sine. So we write it sine of x equals the opposite, which is 12.5, over the hypotenuse, which is 15. But since we are looking for x, we can't have this sign here. So then when we move it to the other side, or when we're trying to figure out what our angle is, we have to do inverse sine of 12.5 over 15. Okay, and so the inverse sine, let me go ahead and delete this, of 12.5 divided by 15. Enter. That gives me 56.4. So x, my angle x, is equal to, if I round to the nearest degree, it will be 54 degrees. Okay, so here's our next one. Our angle that they give us is here, and the 17 happens to be opposite that angle. Okay, now this side right here, it's either the adjacent or the hypotenuse, and so it's obviously not the hypotenuse because it's not the longest side, so that makes it adjacent then. Okay, so opposite and adjacent is going to be my tangent function. So tangent of x is equal to my opposite, which is 17, over my adjacent, which is 17. Okay. So since we are looking for x, that tangent needs to move to the other side, and when we do move it, we use the inverse tangent of 17 over 7. Okay, so second, inverse tangent of 17 over 7. And that rounds to 67.6, which would round to 68 degrees. Okay, so here, the next one, here we have angle x. So this one is going to be my adjacent side, and this one's going to be my hypotenuse. Okay, so adjacent hypotenuse is going to be my cosine. And we're finding of x degrees equals 16 over 20, adjacent over hypotenuse. And so here, we're solving for x, so I'm going to have to move the cosine to the other side. So it'll be cosine inverse of 16 over 20. And when we put that in our calculator, so let me go ahead and clear this. And I'm going to do inverse cosine of 16 over 20. And that gives us 36.8, which would round to 37 degrees. Okay. Okay, the next one, it says solve the following problem. So here it says a wheelchair ramp. Oh, it froze on me. Okay, there it goes. A wheelchair ramp has a slope of 1 over 20. That means that it rises 1 foot from the ground, and it has a horizontal length of 20 feet. To the nearest degree, find the angle the ramp makes. Okay, so they give you this little picture, and so it says it raises 1 foot for every 20 feet that it comes across. Okay, so then it wants to know what is the angle that the ramp makes with the horizontal. So this is a horizontal, okay? So it's looking for what angle is this one right here, okay? Which makes the one opposite and the 20 feet the adjacent side. So that means that we're gonna have to use tangent, tan of x. We don't know what our angle is. X degrees equals the opposite, which is 1 over adjacent, which is 20. Okay, so to solve for x, when we're looking for the angle, we're supposed to use inverse tangent. So inverse tangent of 1 over 20. So I'm going to put that in my calculator. Let me clear this. We're going to put inverse tangent of 1. Oh, that came out ugly. 1 over 20. We hit enter, and that gives me 2.86. So does it tell us what to round to? Let's see. To the nearest degree. So 2.86 would round to 3 degrees. So that means that the ramp has to be 3 degrees, okay, up. Okay. And the last one here, it says Baldwin Street in Dunedin, New Zealand is the steepest street in the world. It has a grade of 38%. To the nearest degree, what angle does Baldwin Street make with the horizontal? So it says 38% is equal to 38 over 100. So that means that a 38% grade means a hill rises 38 feet for every 100 feet of a horizontal distance. Okay, so pretty much you have this road and it happens to be very steep. So that means that it kind of goes pretty high up. Okay, so it says that the height is 38 because it is a 38% grade over 100. So if you've ever been to a hill, you'll notice there's a sign that'll say 38% or 26% or 15%. That's telling you how steep the street is, okay? So here, it's trying to figure out which angle we're trying to find. It says, what angle does Baldwin Street make with the horizontal? So that would mean that they are talking about this angle right here. Okay, so that makes the 38 opposite and the 100 adjacent, which means we are going to use a trig function tangent, okay, because tangent is opposite over adjacent. We don't know what the angle is. We're going to call it x. Opposite is 38 and adjacent is 100. Okay, so we're going to solve for x by taking the inverse tangent of 38 over 100, and that's going to give us what x is equal to. Okay, once we punch that in our calculators, so let me go ahead and clear this. I'm going to press second tangent of 38. Whoops. 38 over 100. Okay, that is not what I want. It's 38. And that gives us 20.8, which would be 21. So that angle makes 21 degrees. Okay, so that's it for me for today. If you have any questions, we will leave it in the comments and we'll talk to you later.